Metal-clad cable, often referred to as MC cable, requires specific methods for secure installation to wood framing. The National Electrical Code, or NEC, sets the standards for safe electrical practices, and these standards dictate the approved methods for securing cables. The use of staples for securing MC cable to wood framing is not an approved method. The primary reason for this prohibition lies in the potential for damage to the cable. Staples, when driven into wood, can easily penetrate or crimp the outer jacket of the MC cable. This damage can compromise the integrity of the insulation surrounding the conductors within the cable, leading to potential short circuits, ground faults, and even electrical fires. Furthermore, staples do not provide adequate support for the cable, particularly over longer spans. The weight of the cable can cause it to sag, placing stress on the conductors and potentially leading to premature failure. The NEC mandates the use of specifically designed cable straps or supports for securing MC cable. These straps are typically made of metal or plastic and are designed to cradle the cable without causing damage. They provide a secure and reliable means of support, ensuring that the cable is properly protected and that the conductors are not subjected to undue stress. MC straps are designed to distribute the weight of the cable evenly, preventing sagging and maintaining proper spacing between the cable and the wood framing. This spacing is important for heat dissipation and helps to prevent the cable from overheating. When installing MC cable, it is essential to use the correct size and type of strap for the cable being installed. The NEC specifies the maximum spacing between straps, which is typically every 4.5 feet for horizontal runs and every 6 feet for vertical runs. However, these distances may vary depending on the specific application and the type of cable being used. Always refer to the NEC and the cable manufacturer's instructions for specific requirements. In addition to using the correct type of strap, it is also important to install the straps properly. The strap should be securely fastened to the wood framing using screws or nails that are long enough to penetrate the framing member adequately. Avoid over-tightening the straps, as this can damage the cable. Instead, tighten the straps just enough to hold the cable securely in place. When running MC cable through holes in wood framing members, it is important to protect the cable from abrasion. This can be accomplished by using grommets or bushings to line the holes. Grommets and bushings provide a smooth, rounded surface that prevents the cable from rubbing against the sharp edges of the wood. In addition to protecting the cable from damage, proper installation of MC cable also helps to ensure the longevity of the electrical system. By using approved methods and materials, you can minimize the risk of problems such as short circuits, ground faults, and electrical fires. This, in turn, can save you time and money in the long run by reducing the need for repairs and replacements. When working with electrical wiring, it is always important to follow the NEC and any other applicable codes and regulations. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. Firstly, always de-energize the circuit before working on any electrical wiring. Secondly, use appropriate personal protective equipment, such as safety glasses and gloves. Thirdly, double-check your work to ensure that all connections are secure and that the wiring is properly installed. Understanding the correct methods for securing MC cable is a crucial aspect of electrical safety. By adhering to the NEC and using approved materials and techniques, you can ensure that your electrical installations are safe, reliable, and compliant with applicable codes and regulations. Remember that while staples may seem like a convenient and inexpensive way to secure MC cable, they are not an approved method and can pose a significant safety hazard. Always use MC straps or other approved supports to ensure the integrity and safety of your electrical system. It is also important to note that different types of cables may require different methods of support. For example, non-metallic sheathed cable, often referred to as NM cable or Romex, has different requirements for securing and supporting the cable. NM cable can be secured with staples, but the staples must be specifically designed for use with NM cable and must be installed in accordance with the NEC. The NEC specifies the maximum spacing between staples for NM cable, which is typically every 4.5 feet for horizontal runs and every 6 feet for vertical runs. In addition, the staples must be installed in a manner that does not damage the cable. This means that the staple should not be over-tightened or driven in at an angle that could cause them to penetrate the cable jacket. When working with any type of electrical cable, it is always important to refer to the NEC and the cable manufacturer's instructions for specific requirements. These resources will provide you with the information you need to install the cable safely and correctly. Another important consideration when installing MC cable is the bending radius of the cable. The NEC specifies the minimum bending radius for MC cable, which is typically 5 times the diameter of the cable. This means that the cable should not be bent at a sharper angle than 5 times its diameter. Bending the cable at too sharp of an angle can damage the conductors within the cable and can lead to premature failure. When running MC cable around corners, it is important to use a smooth, gradual bend that does not exceed the minimum bending radius. This will help to protect the cable from damage and ensure that it remains in good condition for years to come. In addition to the bending radius, it is also important to consider the ampacity of the MC cable. Ampacity is the maximum amount of current that a cable can safely carry. The ampacity of a cable is determined by its size, type, and insulation rating. The NEC provides tables that list the ampacity of various types of cables. When selecting MC cable for an electrical installation, it is important to choose a cable with an ampacity that is sufficient to handle the load. This will help to prevent the cable from overheating and potentially causing a fire. For example, if you are installing a 20 amp circuit, you will need to use MC cable that is rated for at least 20 amps. The NEC specifies the minimum size of conductor that is required for a 20 amp circuit, which is typically 12 American wire gauge or AUG copper wire. However, the actual size of conductor that is required may vary depending on the specific application and the length of the run. When in doubt, it is always best to consult with a qualified electrician to ensure that you are using the correct size of cable for the load. The National Electrical Code, specifically Section 330.30, outlines the requirements for securing and supporting MC cable. This section emphasizes that MC cable must be supported and secured by staples, cable ties, straps, hangers, or similar fittings designed and installed so as not to damage the cable. The intervals for support are crucial. For concealed work, MC cable must be supported and secured at intervals not exceeding 6 feet. For exposed work, the intervals are closer, requiring support and securing at intervals not exceeding 4.5 feet. This is to prevent sagging and potential damage to the cable. Additionally, within 12 inches from every box, cabinet, fitting, or other cable termination, the MC cable must be secured. This ensures that the connections are not strained and remain secure. Another key point is the protection of MC cable where it is subject to physical damage. Section 330.17 of the NEC addresses this issue, stating that MC cable must be protected from physical damage where necessary. This protection can be achieved through various means, such as conduit, guard strips, or other approved methods. The goal is to prevent any impact or abrasion that could compromise the cable's integrity. When MC cable passes through wood or metal framing members, it is essential to protect it from sharp edges. Section 300.4, titled Protection Against Physical Damage, provides guidelines for this. In wood framing, the cable should be protected by bushings or grommets where it passes through holes. In metal framing, the edges of the hole should be smooth and free of burrs, or bushing should be used to prevent abrasion. For installations in damp or wet locations, it is important to use MC cable that is listed for such environments. The NEC specifies the types of cables that are suitable for wet locations, and it is crucial to select a cable that is designed to withstand moisture and corrosion. This ensures the long-term reliability and safety of the electrical system. When installing MC cable in concealed locations, such as within walls or ceilings, it is important to follow the NEC guidelines for fire stopping. Fire stopping materials are used to seal openings around cables and other penetrations to prevent the spread of fire and smoke. The NEC specifies the types of fire stopping materials that are approved for use and the methods for installing them properly. In addition to the NEC, local codes and regulations may also apply to the installation of MC cable. It is important to check with the local electrical inspector to ensure that your installation complies with all applicable requirements. This will help to prevent any delays or problems during the inspection process. When working with MC cable, it is essential to use the correct tools and equipment. This includes cable cutters, strippers, and connectors that are specifically designed for use with MC cable. Using the wrong tools can damage the cable and can lead to unsafe conditions. Always follow the manufacturer's instructions when using these tools and equipment. Proper grounding of MC cable is crucial for safety. The NEC requires that MC cable be grounded in accordance with the provisions of Article 250, which covers grounding and bonding. Grounding helps to protect against electrical shock and reduces the risk of fire. The grounding conductor within the MC cable must be properly connected to the grounding system of the building. When terminating MC cable at boxes and enclosures, it is important to use approved connectors. These connectors are designed to provide a secure and reliable connection between the cable and the box. They also help to protect the cable from damage and prevent it from being pulled out of the box. The connectors must be properly tightened to ensure a good electrical connection. When installing MC cable in parallel runs, it is important to maintain proper spacing between the cables. The NEC specifies the minimum spacing requirements for parallel runs of MC cable. This spacing helps to prevent overheating and reduces the risk of inductive reactance, which can cause voltage drops. The spacing requirements may vary depending on the size and type of cable being used. When installing MC cable in areas where it may be exposed to corrosive substances, it is important to use cable that is specifically designed for such environments. Corrosion-resistant MC cable is available with special coatings or jackets that protect the cable from damage. This type of cable is often used in industrial settings or in areas near salt water. When installing MC cable in areas where it may be exposed to extreme temperatures, it is important to use cable that is rated for the temperature range. The NEC specifies the temperature ratings for various types of cables. Using cable that is not rated for the temperature range can lead to premature failure and can create a safety hazard. When installing MC cable in hazardous locations, it is important to follow the NEC guidelines for such environments. Hazardous locations are areas where there is a risk of explosion or fire due to the presence of flammable gases, vapors, or dust. The NEC specifies the types of cables and equipment that are approved for use in hazardous locations. When installing MC cable in healthcare facilities, it is important to follow the NEC guidelines for such environments. Healthcare facilities have special requirements for electrical systems to ensure patient safety. The NEC specifies the types of cables and equipment that are approved for use in healthcare facilities. When installing MC cable in dwelling units, it is important to follow the NEC guidelines for such environment. Dwelling units have specific requirements for electrical systems to ensure the safety of the occupants. The NEC specifies the types of cables and equipment that are approved for use in dwelling units. Remember to prioritize safety and compliance with the National Electrical Code when working with MC cable. Staples are not approved for securing MC cable to wood framing due to the risk of damage and inadequate support. Always use MC straps to ensure secure and compliant electrical installations.